everyone. So for this video, we're going to go over rational equations. And the first thing that I want to do is define what a rational equation is, in case probably you have heard of it, but maybe you have already forgotten what they are. So basically, these are just equations that contain rational expressions, or in other words, equations that have fractions with variables either on the numerator or denominator. And there are 3 steps that we need to follow in order to be able to solve rational equations. The first step is to find the least common denominator, or also known as LCD. And this is basically that number that we need to find, and that we want to, the number into what we want to convert all the denominators into. So what do I mean by that? Let's remember that when we're trying to add or subtract, like common fractions, just with numbers, we need the same denominator in the bottom, right? And what we do is we find the LCD, and the LCD is that number that we're going to convert to for the denominators, right? So let's say you have 5 and 2, so then our LCD will be 10, so that means that you want to convert the 5 into a 10 and the 2 into a 10. So that is the LCD, is finding that least common denominator or least common multiple. We usually use the timetables to remember what is the least common multiple, or we can also go ahead and use prime factorization and then find the product of the prime factors to find the LCD. Now, step number 2 is to multiply each side of the equation by the LCD. So that means we want to multiply every single term in the equation by the least common denominator. And step number 3 is to solve for the variable, and that includes simplifying the equation and then getting the variable isolated into one side of the equation. So let's go ahead and start with a more simple example. This is going to be example 1, and it is 2a. I'm not even going to draw. There it is. So 2a minus 3 over 6 equals 2a over 3, and then plus 1/2. So as you can notice, all of our denominators are different, right? So what we want to do is find the LCD. So for my LCD, what I'm going to do is I'm going to go ahead and break all the numbers into prime factors if they are not prime. For instance, 6, right? This is step number 1. So 6 is 2 times 3. 3 is a prime factor, so this is just going to say it's 3, and 2 is also a prime factor. So our LCD, it's going to be the prime numbers that we find, right? And then let's say if one of these prime numbers appears more than once, then you're going to put it down for the LCD as many times, or the maximum amount of times that it appears. For instance, here the number 2 shows up only once in 6 and only once in 2. So then our LCD is going to have 1, 2 times. Then we also have the number 3, which also appears only once with the 6 and then once with 3, so you only put it once. So 2 times 3 equals 6. So that means that the LCD is 6. Now you probably already knew this, but this is just a different way of finding the LCD. Okay. So for step number 2, we need to multiply every single term in the equation by the LCD, so by 6. So we have 2a minus 3 over 6 equals 2a over 3 plus 1 over 2. And then we're going to multiply every single term by 6. Now, what we want to do is we want to reduce the denominator in the bottom with that LCD, with that 6 that we're multiplying, right? So for instance, here we have 6 over 6. That is actually going to give us 1 because they're both can be reduced by 6, right? So 6 goes in 6 ones. And I erase that by accident, so 6 there. And then the 6 on the bottom goes in 6 ones as well. Now let's go ahead and talk about 6 and 3. They're both divisible by 3, so 6 divided by 3 is 2, and 3 divided by 3 is 1. And then 6 and 2 are also divisible by 2, right? So 6 divided by 2 is 3, and then 2 divided by 2 is 1. So then we are left with 1 times 2a minus 3. I'm not even going to bother to put the one that it's left in the bottom because I know that 2a minus 3 divided by 1 is still 2a minus 3. And let's remember that a fraction means division, right? Equals 2 times 2a. Same thing is happening, right? We have a 1 on the bottom. However, I'm not even going to include it because it's not changing the value of 2a. And then plus 3 times 1. Okay. So now what we want to do is simplify both sides of the equation until we find the value of a. So 1 times 2a minus 3, it's 2a minus 3. Now this 2 times 2 is 4a, plus 3 times 1 is 3. So now that we want to solve for the variable, what we want to do is move all the terms with variables into the same side. So we don't want them split into the right side of the equation and the left side of the equal sign. So here I'm saying that I have a 2a on the left and then a 4a on the right. And what we want to do in this case is always move the term that has the lowest coefficient or the lowest number, right? That also includes negatives. Let's remember that. The higher the negative value is, the lower the actual value it's going to be. So here, we're going to go ahead and move that 2a to the other side by subtraction because it's positive here. So I'm going to go ahead and do minus 2a, minus 2a. So 2a and negative 2a are going to cancel. We are left with negative 3 on the left. And then 4a minus 2a, it's 2a and then plus 3. Now, I want to isolate the a. That means that I need to get rid of the 2 and the positive 3. Because 3 is adding and 2 is multiplying, it's easier to get rid of the 3 first and then work with the 2. So 3 is adding, we're going to subtract it to the other side. So now we have negative 3 minus 3, which is negative 6, equals to a, divide by 2, negative 3 equals a. Okay, so we found a value for it. Now let's go ahead and prove that this is an actual solution. How do we do that? We're going to plug in negative 3 into the original equation, and then we're going to check if whatever we get, it's true, right? If we get a true statement, that means that both sides of the equations have to be equal. So I have 2 times negative 3. Notice how it was 2a before, but now that we have a negative 3 as a value for a, we plug it in. And then minus 3 over 6 equals 2 times negative 3 over 6 plus 1/2. And that should be over 3. So here we will have negative 6 minus 3 over 6 equals negative 9 over 3 plus 1 over 2. And that shouldn't be a negative 9. That should actually be a negative 6. So negative 6. So negative 6 minus 3, it's going to give us negative 9 over 6. And now let's go ahead and multiply this side by 2 and this side by 3. So now we have negative 6 times 2, which is negative 12 over 6 plus 3 over 6. And then where we have negative 9 over 6 equals negative 12 plus 3 is actually negative 9. Now we were able to combine the top numbers because we have the same denominator. Okay, so this is example number 2. And for this one, you'll notice that Now, our rational expressions do have variables, right, in the denominator, whereas on the previous one, we only had variables on the numerator. So let's go ahead and find the LCD, given that that is the first step. And when we have denominators that only have one variable, and that variable it's the same, all we need to worry about is the numbers, the leading coefficients, right? So here we notice that the only difference between 5x and 2x is that number in the front, right? The fact that we have a 5 over here and we have a 2 over here. However, x is already the same, so we don't have to worry about that one. But let's go ahead and find what will be the least common denominator for 5 and 2. Given that 5 and 2 are prime numbers, then all we need to do is find their product. So 5 times 2 equals 10, right? However, we're going to include that x, right, that they both have. So our LCD is 10x. So on step 2, we're going to be multiplying the entire equation by 10x. So I'm going to go ahead and have 10x, and then it's going to multiply 3 over 5x. Let me first rewrite the entire equation and then multiply. Okay. So again, I'm multiplying everything by 10x, right? And so basically what I want to do is reduce that 10x with the denominator that I have in the bottom. And basically by multiplying for the LCD, the entire equation, it's going to, be for us to be able to cancel out those denominators that we have. So here I can see that I have an x here on the top with the 10x and then x on the bottom. So the x and the x can cancel out. And then 10 over 5, they're both divisible by the number 5. So 10 becomes 2 and then 5 becomes 1. So something similar is happening with the fraction in the middle. X and x are going to cancel out. 10 and 2 are both divisible by the number 2, so 10 will become 5 and 2 will become 1. And then here 10x times 1 over 1 is just going to stay as 10x. We don't have an x on the bottom or a number by which 10 can be divided by, right? 1 is just going to still make it a 10. It's not going to change. So this is just going to stay as it is. So if I rewrite what I have left, I will have 2 times 3 plus 5 times 7 equals 10x times 1. And now we are in step 3, which is where we have to simplify and then solve for the variable. So here we have 2 times 3, it's 6, plus 5 times 7, it's 35. Equals 10x times 1, it's 10x. Now I'm going to go ahead and add 6 plus 35 so I can simplify the left side. So this will be 41 equals 10x. And now I will divide by 10. So 10 and 10 are going to cancel out on the right. So I have x equals 4.1. Okay. And that'll be the end for example 2. Okay everyone, so now I'm going to go over a different example. This one as well is going to have variables on the numerator as the first example that we did, but we're also going to have variables on the denominator, and this time we're actually including an addition for one of the fractions. So we have 5k over k plus 2 over k equals 5. And let's remember that whenever we have an integer or a whole number, we want to include a 1 under that value. Okay, that way we can see like the entire equation written into a fraction form. So whenever we have additions and then like variables on the denominators, we can even say that it's a little bit easier to find our LCD because the LCD is going to be the product of all the different values that we have. So for instance, k plus 2, we don't have a k plus 2 on any of the other two fractions, so we're going to have k plus 2 times k, right? We don't have just like one single k on the first fraction or the third one, so times k and then times 1. So our LCD is k plus 2 times k times 1. So on the second step, what we want to do is we want to multiply again that LCD by every single term in the equation, right? So let's go ahead and rewrite the equation and leave some space. So we're going to multiply the first fraction by k plus 2 times k, and then times 1. I'm not going to include the 1 because the 1 is going to preserve just the value of k plus 2 and k. So now that I am multiplying every single term by the LCD, what I want to do is find, that relation between the denominator and those values that we're multiplying. So what do I mean by that? By finding the LCD, basically that's gonna help me get rid of the denominators. And basically we get rid of those denominators if we see the same value as the denominator coming up on that LCD, right? So for instance, on the first one we have a k plus 2 and then k plus 2, so these two are going to cancel out. In the middle one we have a k and k, so that is also going to cancel out. And then for the last one, we don't have k plus 2 or k in the bottom, so that's just going to stay as it is, k plus 2 times k and then times 5. So now let's go ahead and rewrite what we have. So this is k times 5k plus k plus 2 times 2 equals k plus 2, k, and then 5. Okay. So now that we have this, we're going to go ahead and do that step 3, which is solving for the variable, and that includes simplifying the equation. So I'm going to go ahead and multiply k times 5k, which is going to give me 5k to the second power, plus k plus 2 times 2. 2 will multiply both values, so it will be 2k plus 4 equals, and then here we want to multiply everything, right? So I'm going to say k plus 2 times 5k, and then the 5k will be distributed, so it's going to become 5k to the second power plus 10k, and then on the other side we have 5k to the second power plus 2k plus 4. Okay. Now I can see that I have k's on the left and then k's on the right. So what I'm going to do is I'm going to go ahead and move the values on the right to the left. And let's start with 5k squared because it's positive. We're going to move it as a negative. So this will eliminate. And then we happen to have the same value, right? Positive on the left, which is 5k squared, so it's also going to eliminate. Now we have 2k plus 4 equals 10k. So from here we're going to do what I mentioned on example 1. We want to move the term that has a variable with the lowest coefficient. In that case is 2k, so I'm going to go ahead and subtract 2k. So 2k and 2k are going to cancel out, and then I'm going to have left 4 equals 10 minus 2, which is 8k. Now, I want k isolated because I basically want to solve for that variable, so I'm going to go ahead and divide by 8. So then 4 divided by 8 is 1/2, which equals k. And there we found the solution. Okay, so example 4, it's really similar to example 3. We see that we have an addition and a subtraction on the denominator. However, now we have it in both fractions, right? And then we have 4x over 3x minus 2 plus 2x over 3x plus 2 equals 2. And then we include a 1 under the 2, right? So we can have everything in a fractional form. So LCD, remember I told you that if we have a plus, basically an addition or subtraction on the denominators, we are basically, if we don't have the same denominators or anything in common, our LCD is just going to be the product of the different denominators. So in this case, it'll be 3x minus 2 times 3x plus 2. And then times 1, but again, I'm not going to include the 1 because that's not really going to change the LCD, right? So just 3x minus 2 times 3x plus 2. So step number 2 is we're going to multiply the entire equation by the LCD. So I'm going to have 4x over 3x minus 2. Let me write it down first. Plus 2x over 3x plus 2 equals 2 over 1. And I'm going to multiply every single value by the LCD, which is 3x minus 2, and then 3x plus 2. So also, we're also going to do it for the second fraction, 3x minus 2 times 3x plus 2. And then for the last one as well, 3x minus 2 times 3x plus 2. So for the first fraction, I can see that I have 3x minus 2. So this is going to go away with this one. And then on the second fraction, I have 3x plus 2. So the second one is going to go away with it. And then on the third one, we don't really have any denominator, just 1. So we're going to multiply all of these values, 3x minus 2, 3x plus 2 times 2. And this will be 3x plus 2 times 4x plus 3x minus 2 times 2x equals, and then 3x minus 2, 3x plus 2 times 2. So we are already jumping into step 3, which is solving for the variable. And what we want to do is simplify both sides of the equation as much as we can. Okay. So here 4x will multiply 3x and 2, which is 12x to the second power. And then 4x times positive 2 is 8x. Plus, and then same thing here. So 2x times 3x will be 6x to the second power. And then negative 2 times 2x is going to be minus 4x. Equals, and then let's go ahead and distribute this. So 3x will multiply those two, and then negative 2 will multiply these two. So we're going to have 9x squared plus 6x and plus 6x, and then minus 6x and minus 4. And then all of that is being multiplied by 2. So here on the left side, I'm noticing that I can go ahead and combine 12x squared with 6x squared. And then we can also combine positive 8x and then negative 4x. So 12x to the second power plus 6x to the second power will be 18x to the second power. And then 8x minus 4x is just going to be positive 4x. Now, for the right side, I can see that we have two 6x, one positive, one negative. I'm going to go ahead and cancel those. And I'm going to end up with 9x squared minus 4. And then times 2. So this 2 will be distributed to 9x squared and negative 4. So I'm going to have 18x to the second power plus 4x equals 18x squared and then minus 8. Now I'm going to go ahead and subtract 18x squared. So I'm left with 4x equals negative 8. And then I'm going to divide by 4. So x equals negative 2. And we're done with number 4. Okay, so now we're going to go over the last example for rational equations. And as you can see, on this particular problem, we have now a denominator that contains a trinomial. Trinomial means that we have an expression with variables that has 3 terms, which is the one with k squared minus 8k plus 12. Right? And so let's go ahead and talk about what we can do in order to find the LCD, which might be the hardest part of this exercise compared to the other ones. And then I'll guide you on how can we solve for k on this equation. So the first thing that we want to do is we want to factor that that expression that we have right there. So we want to factor this. We want to write that in 2 parentheses that will be multiplying each other. Now, how can we do that? Well, the first thing that we're going to do is we're going to create this x, this big X. And on the top, we're going to put the last number, which is positive 12. And then on the bottom, we're going to put that number in the middle that has the k, right? So negative 8. Okay. Now, what you want to do is find 2 numbers that multiply to positive 12 and add to negative 8. Okay. So those 2 numbers are actually negative 6 and negative 2. So negative 6 times negative 2 gives us positive 12, and negative 6 plus negative 2 gives us negative 8. So that means that this fraction can be written as 4 over k minus 6 and then k minus 2. So I basically took those 2 values and I put them here with the k, right? And then we have k and k because we have a k squared. And then our right side is going to stay the same. Okay, so now that we have this, we can go ahead and try to find the LCD. So for our LCD, let's remember that if we have additions and subtractions on the denominators, then we're going to have to find the product, right? Or LCD will be the product of all the denominators. So in this case, I see that k minus 6 appears once on the first and the last fraction. So I'm just going to put k minus 6 once. Then I'm also noticing that k minus 2 appears once, right, as well. So because it only appears once, so the most repetitions of k minus 2 is actually 0, so just 1. So this will be times k minus 2. So that is our LCD. Now what we want to do is we want to multiply every single term by the LCD. So we're going to have 4 over k minus 6 times k minus 2 equals, and then we have k over k minus 2, and then plus 1 over k minus 6. And I'm going to multiply each of those terms by the LCD. So my LCD for the first one is k minus 6, and then k minus 2. And that's going to be for every single fraction. So now, again, we want to reduce, so from the top to the bottom, or from the top right to the ones on the bottom. So the denominator. So here I see that I have a k minus 6, right? And I also have a k minus 6 on the bottom, so this can cancel out. And then I have a k minus 2 and a k minus 2, so this also it's going to eliminate. So all that I have left is 4. Now for the other equation, k minus 6 times k minus 2 times k over k minus 2, I can see that k minus 2 is the only one repeated. So I will have k minus 6 times k. And then something similar is happening with the last fraction. So k minus 6 will be canceling out with the denominator, so we are left with 1 times k minus 2. So now that was step 2. Now we are on step 3, which is solving for the variable. So that means simplify as well. So k will multiply the k and the 6. So we have k squared minus 6k, and then plus k minus 2. So now what I'm going to do is I'm going to go ahead and combine the like terms. So negative 6k and positive k. So we have 4 equals k squared minus 5k minus 2. And what I'm going to do is I'm going to go ahead and subtract 4 on both sides. So then all of the values are going to be on the right side of the equation. So I'm going to have k squared minus 5k minus 6. And again, we want to find two parentheses where the two numbers, right, multiply to the last one and add to the one in the middle. So multiply and then add. So two numbers that multiply to negative 6 and add to negative 5, it's actually positive 1 and negative 6. So this will be k plus 1, k minus 6. And then we have the zero product property, which says that when you are multiplying two items and the product or the answer is 0, then one of those two items has to be 0. So here in this case, either k plus 1 equals 0, or k minus 6 equals 0. And then let's go ahead and solve for k. So here it was a plus 1, so I'm going to go ahead and subtract it. And then on this side, I'm going to go ahead and move the 6 to the other side. So k equals positive 6. Okay, so now that we have got our two solutions, our k equals negative 1 and k equals 6, I'm going to go ahead and plug in to check if they both work, right? By that I mean that I'm not going to have a 0 on the denominator if I plug them in. So for the first one, so this is check. K equals negative 1. I have 4 over k squared minus 8k plus 12 equals k over k minus 2 plus 1 over k minus 6. So if I plug in negative 1, I will have negative 1 squared minus 8 times negative 1 plus 12 equals k over negative 1 minus 2 plus 1 over negative 1 minus 6. and this will become 4. And actually, this k is actually also changing to -1. So 4 over 1 plus 8 plus 12 equals -1 over -3 plus 1 over -7. So this is 4 over 1 and 8 is 9, and then 12, it's going to be 21. So 1 over 3 plus 1 over -7. So here, we don't have any undefined solution, right? So k equals -1 is actually going to work. We also know that this right here, right, we multiply times 7 and then times 3. So we end up with 4 over 21 equals 7 over 21 minus, I'm going to bring that negative up here, minus 3 over 21, which is 4 over 21. So -1 works. So this one works. Now let's go ahead and try k equals 6. I'm going to go ahead and do it, this. And now I'm going to go ahead and try k equals 6. And I'm going to have 4 over 6 squared minus 8 times 6 plus 12 equals 6 over 6 minus 2 plus 1 over 6 minus 6. And here is where I have a problem, because this right here will become 1 over 0. That's already undefined, not working, so k equals 6 is not a solution. So the only solution that we're going to consider for this particular problem is going to be k equals -1. Okay?